All right, welcome to the Sustainable Materials Management webinar series, a joint effort between the National Recycling Coalition and the Pennsylvania Recycling Market Center. My name is Wayne Bowen. I'm the program manager for the Recycling Market Center and will serve as your moderator today. Before we get started with the presentation, we would like to extend a special thanks to Bob Hollis of the Mobius Network for providing the webinar management software for this series. The focus of today's webinar is on the past, present, and future of Murph equipment. Today's presenter is Nathiel Egosi, who I will introduce in a moment. Following his presentation, we will conduct a question and answer session. If you have a question or comment, please use the GoToWebinar dialog box located in the control panel on your screen. You may also use the dialog box to request assistance if you're experiencing technical difficulties during the webinar. Please note that an edited version of this webinar will be made available for viewing via YouTube links on the National Recycling Coalition and Pennsylvania Recycling Market Center websites. The presentation slides can also be obtained using the handout upload feature on your webinar control panel. And now I'd like to introduce our presenter. Nathiel Egosi is President and CEO of RRT Design and Construction, a national leader in the engineering and construction of solid waste processing and recycling facilities. Since 1989, Mr. Egosi has led the development and construction of over 100 greenfield material recovery facilities nationwide and has pioneered the development of advanced technologies for recycling paper and solid waste industries. He's widely recognized as an expert in the process engineering and equipment design for the recovery of materials and energy from solid waste, food waste processing, metals from ash, processing of waste materials into engineered fuels, and advanced material beneficiation and refining of waste for reuse. His experience also includes retrofits, expansions, and upgrades at over 300 recycling facilities. Mr. Egosi is a registered professional engineer in 23 states and graduated summa cum laude with a degree in civil engineering from the Polytechnic Institute of New York, now NYU Polytech. Mr. Egosi is a frequent speaker, has authored numerous technical papers on the subject of solid waste processing and material recovery technologies, and also is a patent holder for plastics recycling process. Okay, I'm now going to turn the program over to Mr. Egosi.
Okay, so good morning to our West Coast attendees and good afternoon to the East Coast attendees. Pleasure to be here. I will make a presentation here on the past, present, and future of Murph equipment. Just a quick overview of our company. As Wayne mentioned, we design and we've built solid waste processing facilities and businesses for nearly 30 years, some 400 plants, 80 of them are greenfield, and just some quick photos there. So trying to see if we can have a little fun here and go through the topics that we will be covering. A perspective on the evolution of recycling processing equipment, that's the core part of what we're covering, and the key drivers that determine what a future Murph might look like as we go forward. And the agenda items are the drivers, the trends, the history, the equipment, subjects, and we'll also spend a little bit of time discussing retrofits given the state of where we are with our Murph infrastructure. So what is the future? Well, certainly the future is a reflection always of the past, and what we can see is much more commingling of materials, more types of materials, continuation of the lightweighting that we all are familiar with, where there's more units per pound, integration with collection, use the careful integration of how material is collected and brought to a Murph to be processed, substantially more automation, the private sector gaining substantially more of the market share in terms of how Murphs are being owned and operated, although the public still has a very significant role in Murph ownership and operation. What are the economic drivers and the yin and yang of the markets? So just a quick overview in terms of what is the state of the Murphs. There's about 700 plus Murphs in the United States, probably starting to push close to 800, but we're still in the 700. And I like to refer to it as the 80-20 rule, where 80% of the Murph processing is done by 20% of the actual facilities. So the point there is that there are a lot of Murphs, some 700 plus, but many of them are rather small or on the smaller side. With regard to the players, you have the large publicly traded companies that are national and have facilities spread out across various metropolitan areas, counties, and states. You have large regional facilities in different pockets of area, whether it's the Northeast of the United States or the Southern California as an example. And you have individual players that own and operate or are a third-party processor for one or two facilities just around a particular community within an area, like, for example, in northern Jersey as an example. These MRFs largely are all self-driven, meaning the industry sort of works on its own. These facilities are contractually based with haulers, contractually based with municipalities. They're open to the market to receive material, and they live and work through the economics of how recycling works. So in terms of core issues, and the core issues that we're all dealing with and we're looking going forward, is huge investments need to be spent, and then those costs and investments need to be recovered. Another comment is probably about half of the people that are operating MRFs still lack confidence in the business. I don't mean necessarily the plant manager. I mean the folks that are minding the store, whether it's a city council or a board of county commissioners or the board of a publicly traded corporation. 70% of our waste is unprocessed, going straight to a landfill or straight to a waste energy facility. 50% of our waste that is processed is done poorly. I think we all realize that. And there's a preponderance historically of relying on revenues to offset costs of running a MRF. And that confuses what should really be a fee-based structure for a MRF operation. And the PR associated with zero waste adds substantial confusion to the industry. And always, market conditions will dictate the business. And what I mean by the business, I mean the economics, the profitability and the viability economic structure. It's about the market condition. So the business theory, diagrammatically, if we look at it, begins with the generator, sets out the curb, we collect it, we bring it to a MRF to process it. After processing it, shipped, comes to a market, and the end user uses the raw material to make a product, which then goes back into the economy, and hence we've all heard the buzzword circular economy, and that is the business theory. When this works very nicely, everything works nicely in theory. In practice, and we've heard lots of complaining over the last 5-10 years from MRF operators and markets, is the pressure and contamination. The generators provide materials that are not otherwise recyclable, and they're set out at the curb and collected, and they arrive across the line at the MRF. And the pressure of that contamination puts a tremendous amount of pressure on a MRF operator and MRF processing and the equipment. And we've seen that as a very high topic of conversation as recently as 2017, 2016, 2015. It was really the subject of conversation. Now this year in 2018, we are hearing a lot about the pressure of the markets, the end users pushing back on the markets and the markets pushing back to the MRF. So the MRF sits in the middle, feeling the pressure from both sides. And right now the loudest complaints or problems or issues focus around the markets, and the contamination is still very much a large part of the conversation. So getting into the MRF processing, the subject matter with regard to processing, these are the buzzwords that are used in the industry and at your facilities if you have a MRF or you're involved in contractually overseeing a MRF, or is the throughput of a facility. How many tons per hour, tons per day, tons per month, tons per year. It's a unit of measure over time. Recovery rates, what percentage of material that comes in is actually recovered and put back into the marketplace as a commodity. And the balance of it being considered a residue, meaning the material you were unable to recover. Staffing, what's the head count in the facility? Labor is the #1 largest cost of a MRF operation. Maintenance, maintenance and repair of the equipment. We have what's called preventive maintenance, which is doing some of the basic things to keep the equipment going. And then we have the repair. The equipment is subject to the challenges of not only the contamination, also the wear and tear of these different commodities that get processed. and they drive the maintenance costs, but they also drive the availability of the facility, meaning how many hours a day is the facility operational and able to be used versus what somebody would call downtime, meaning the equipment is unable to be used because something is broken, something is jammed, something ripped, something tear, something wore out, something is vibrating, and it's unsafe to be used. So maintenance is an integral part of keeping a facility running. And then, of course, safety, personnel in these facilities. You could have 20, 30, 40, 50 people, maybe even more per shift in a facility, keeping the people safe, keeping the trucks and the truck drivers safe that are arriving on the tipping floor, keeping the forklift operators, bobcats, loader operators safe, and of course the drivers that are coming in to pick up the commodities, the visitors that come through the facility. So there's a lot of activity that goes in the facility. The other business parameters are the material grades. How many different grades are we going to produce? What are the qualities for the grades, and how can those things be marketed and put into the place? So in the aggregate, we look at a system availability and also the efficiency of the equipment. We start looking at different Murphs and we put them side by side, and we're trying to look for comparisons in these facilities. Those are some of the tools that are used. There are challenges, and first of all, many of the challenges to our Murph are external. So let's talk about them. Externally, education. Most places virtually non-existent in terms of the education being provided to the generator about what's appropriate to put out of the curb, and also to the collection company of what's appropriate to be picked up from the back of a truck and brought into a facility. Another challenge is the changes in the mix being the composition of the materials. There is substantially less fiber in the stream, particularly in the newsprint, due to the decline in the newsprint that's been occurring steadily for the last 10 years. The composition of the fiber has changed because of all this brown you can see here in the pile. Some people refer to that as the Amazon effect. But the composition changes not only in the type of fiber, meaning there's more OCC today than there ever was in a residential single stream or dual stream Murph, but also the size of that cardboard is substantially smaller than it otherwise would be. So that also has an impact on the equipment. There is substantially more plastic in total, and different types of plastic, and complex plastics become substantially more complex, some of which is not recyclable. And in general, a ton of material by volume is lighter by weight and more complex. The generator, on the other hand, continues to do what the generator does: purchase consumer goods, use them, dispose them, and throw away. So we have a lot of waste out there to recycle. And ultimately, it's collected. So from the collection side, we see different vehicle types, everything from transfer trailers where material is consolidated at a centralized facility and transferred into a Murph, to automated collection at the curb, like, for example, the photograph you see on the right, which is a side loader. And as a consequence, there is some incoming contamination that's increased. And the moisture content, where you have bins, open bins like the blue box bin you see in the right-hand corner, where it's open to the atmosphere, rain can get in there, and the commodities, in particular the news and the cardboard, get damaged to the point that they're really no longer recyclable. So what's been the response by the business? Well, on the throughput side, as tons are getting what we call lightweighting, meaning the volume of material is increasing in proportion to the weight, composition changes, contamination increasing. The response is either we slow down the lines, the processing lines, to improve quality and running more hours, or running the lines faster to save money. Those are the two tools that are available. Recovery rates. Years ago, maybe 15, 20 years ago, 90% was the standard. Meaning the expectation was 90% of the material that would come in that's recyclable would in fact be recovered and put into market. Then it moved to about 95%, probably in the last 10 years. And now more recently, it's moved up to 98.5%. And that is largely based on tremendous incentives to encourage recycling, commodity prices being quite high, and the general goal in certain market areas to increase diversion. But what we're seeing is the numbers are actually sliding back to something that's more realistic, meaning hitting a high number doesn't accomplish much when you're all done. that you have to send into a landfill, or the markets are just rejecting your loads because what you're claiming is recyclable really is just full of contamination and doesn't meet the market spec. Other business responses are staffing, adding more labor, a lot more labor, particularly what's happening over the course of this year and towards the end of last year with the National Sword on the fiber side, and adding equipment to improve quality, or just simply cutting labor and closing plants to save money. And on the maintenance and safety side, we're seeing significant improvement across many facilities, but the differences can be significant in other plants that are nowhere near at the same level and still operating with maintenance and safety levels that were 15, 20 years old, even older than that. But in general, not enough of a response by the industry.
Hey, Nathiel?
Yes.
Is there any way you can turn up your volume a little bit? There's some folks having difficulty hearing the volume. I have no problem on my computer, but there could be some issues.
All right. Is this any better for everybody?
A little bit of feedback, but it is louder.
Okay. So in terms of industry needs, some of the things that the industry is looking for are education of the public, a fee-based economic structure for the Murph operation, and technology. And technology is a big part of what we want to talk about today. So I'm going to start moving into that. But the frustrations around the technology involve generally a fascination over technology. We all see the ads in the various magazines, whether it's Recycling Today or Resource Recycling, and the many publications like Waste 360. A lot of nice ads and interesting pieces of equipment that could be very useful, and in many cases are extremely useful, but the justifications are weak oftentimes to support the implementation of some of this equipment. Reliability of equipment is still in that 85 to 90% realistically, which is pretty low in comparison to other industries. Screens have plateaued or declining in popularity, and we'll talk about that. Quality of equipment, some claims are honest claims and substantiated, in other cases they're unsubstantiated. Fire and safety, unfortunately we have fires in our industry more than anybody really cares to admit. They're quite common. Some facilities have fires as often as once a month in a facility. And the dust and noise levels are significant. Significant work needs to be done. And then of course you want to add to that everything that we don't control, which is a lot. Hopefully my sound improved a little bit for everybody. Does that sound okay? Maybe Wayne, you can get a read from some of the folks that are attending.
Seems okay.
Okay, very good. I'll continue. So business challenges in the markets is the effort to market is increasing. Market demands are more now than before, particularly with deductions of quality and moisture, and arranging for containers and trailers can be quite difficult, particularly in an export market, and particularly given the fact that the market liquidity in 2018 can only be described as awful. I don't know any other way to say it politely. News will continue to be less available as a commodity grade, and naturally the ONP grade is gone. And the mixed paper grade is growing, hard and soft mix, but it has its challenges this year, in particular with the market liquidity. And on the cross-contamination side, there's just a lot of loss of money in most cases. If we pop open a bale of PET, like in the picture you see here on the left, there will just be a lot of HDP and aluminum and other things in those bales, and it's been going off the market as a PET bale. So we look at this photo, and we say, okay, if you've been in a Murph, you probably have seen this. It's called How to Make a Bale Look Good. Dressing a bale. But in reality, this technique used over the last 5-10 years is in part what's causing now inspectors to actually be on site and inspecting bales, breaking apart bales, and really understanding what's inside that bale, as opposed to a couple guys just trimming the side of the bale to make the exterior look good. But meanwhile, in reality, the interior of the bale has all the contamination you see laying here on the floor that they pulled out. Glass, don't know if I want to get into a big conversation in glass, other than it continues to be a challenge. Some programs are continuing to discontinue glass. It's a challenge everywhere anywhere in terms of marketing. So what are some of the current measures that are being used on the equipment side? Doing plant audits and performance evaluations, moving forward towards a processing-based model, shifting away from sorting screens and modifying what we have, rebalancing the lines, meaning you could have on a Murph, you could have 3 fiber lines based on the split from the different screens, and we may see more material on one line than we ever saw before, and the other 2 lines have very little, so we need to rebalance the lines, and that can make a significant difference. Looking better ways to deal with film. A lot of facilities have put in film collection systems, consuming a lot of electricity, making a lot of noise, not necessarily improving the health environment within the facility. And then the film itself, once it's packaged up into a bale, the markets for those are slim to none in most cases. So ultimately, landfill becomes the path there. Hub and spoke approaches in terms of transferring tons long distances and bringing them into a facility. So more tons into one facility will allow smaller facilities that are not too efficient to be closed down, and the larger facility runs those tons on the second shift. One of the popular things that we're seeing is just removing equipment. Too much equipment in the plant, getting the plants to be simpler, and when removing it, in some cases, replacing equipment with better equipment. One piece of equipment could do the job of 3. And particularly today, a lot of folks are adjusting to the market contraction. And in part, it's leading to Murph closures and Murph stalls. So what are some of the real game changers that occurred in the past 20, 25 years in terms of how we got to where we are? I was asked to talk a little bit about the past. So in the past, and some of the things that have evolved, for example, I'm not going to go through all these, but automated collection is a significant change of technology to get us on the collection side. On the processing side, where we're doing batch baling in the early days of a Murph, you would typically see 1 baler per commodity. You walk in the facility, you could see 5, 6, 7 balers, all small little balers. Now we see 1 baler or 2 balers, and they're baling all the commodities by batch baling. A significant amount of automation was introduced with eddy current separators that were introduced in the early 90s, optical sorters more so in the late 90s, and they've really come into full swing in the last 10, 15 years, where all facilities have them today, certainly any new facility. The use of paper screens with the advent of single stream, and of course the OCC screen. So here's some photos, just from a collection of photos that I've saved over the years. These are quite old, but basically this is how recycling and sorting was being done. People standing in a pit and on a conveyor that would be stopped, and they'd stand in front of a pile and kind of sort the material on a conveyor belt that would be baled, and they would get out of the pit, and then they would wait until the pit clear, and they would repeat this all day long. And some of these photos are really not even that old. Material coming out of a bunker that's going to run up to a baler. This is aluminum. This is a method of doing quality control for aluminum. Hopefully no one's doing this today. Sorting cardboard, as you can see here in this photo. This one is date stamp 96. Here's another one sorting paper on the floor. So big technology leap. This sorting system was invented, and this became the technology breakthrough of having an elevated sorting system. And believe it or not, this was a breakthrough technology in the early 90s. And from there, we started putting people on the line, and in order to accommodate different commodities, you would just need to have a lot of people on the line side by side. And in this case, you see here people sorting glass along a 3-line conveyor. But optical sorting stepped in its place, and optical sorting very effectively displaces the use of all these people and allows for this automated separation of glass, plastic, and paper. And the dominant use has been in the plastic side, but it's growing very rapidly in plastic. And paper, and we'll talk about that. This is what I meant earlier about batch baling, where the commodities are separated into separate bins, and then each bin can be fed individually to the baler that's in the foreground on the left-hand side. Okay, not a pleasant sight to see, but before metering drums were available, this was not an uncommon event where material would be overfed to a line and you would run into this situation. So to avoid this, operators would tend to underfeed to make sure they wouldn't cause this problem to occur. And these are different, more photos of showing what's happening when feeding is not done correctly. So the metering drum or the storage bunker with the drum feeder, people use different terms for it, has allowed material to be fed to sorters in a more uniform rate, which has allowed to avoid these kind of problems you see in the photos here, where there's an avalanche of material, for example, in the lower right-hand corner material, and there's hardly any material in the left side here. Probably one of my favorite pieces of technology that got introduced in the market that really was a significant game changer was the OCC screen. Some people call it the OCC separator. Old corrugated cartons, a device that separates cardboard from everything else simply based on its size, its rigidity, and its ability to bounce across the screens while allowing other things to fall through. Such a simple piece of equipment that really, from a bang for the buck, is incredibly simple and useful in every facility. And by the way, it was introduced somewhere around the 95, 96, 97 period, and still is in everybody's stable as a piece of equipment. Taking a step back on the collection side, very popular, these eager Beaver trucks, which compartmentalized areas where the driver would get out of his cab and dump into the different compartments, the different recyclables, glass in one compartment, metal in another compartment, paper in another compartment, plastic in another compartment. What a struggle those days were. Today, more common is a large bin with a cover on it and a side loader for collection. Driver stays in the cab. So much safer, so much more efficient, and so much more environmentally friendly in terms of the other approach with litter and debris and snow and rain, etc. Moving along on technology, single stream. The single stream paper screen allowed communities to consolidate their containers with their fiber into a single stream, allowing for easier collection, higher recovery rates. But on the other hand, it also requires substantially more investment in equipment to separate everything back into the individual constituents of paper, glass, plastic, and paper. So these paper screens get that job done. The very first larger scale facility was around 1997 in California. You can see here in construction, actually our company, the facility that built it. You can see the orange guarding on the 2-deck screen here. How we see the Murph trends, everything prior to today basically is more or less a historical division of the different types of Murphs, with single stream continuing to grab the larger share, but there's still a very large percentage of 2-stream facilities. And of course, we have all the small drop-off centers, community residential collection programs at bins that are source separated. Some game changers at Murph that didn't take, for example, was putting all your recyclables in a plastic bag and having collected at the Murph and then brought into a machine that would debag it. Thankfully, that technology didn't go forward. Other technologies were, for example, perforating the plastic because the balers were incapable of making a bale of plastic without all the bales falling apart. Well, we've overcome that problem, so no more perforators in our facilities. People had the idea of, why can't we add textiles? Why can't we add wood? Well, thankfully that idea went away. So there's been a lot of different ideas of different people have had nationwide to try to make changes to Murph operations. Some examples took and some didn't. So what's the future? Well, the future is, as we mentioned earlier, more commingling, more materials types, integration with collection, and definitely seeing the private sector being substantially more focused in on their activities, communicating what's going on in the facility, being very transparent on their costs, and being much more let's call it customer oriented in terms of generators and also municipalities in sorting through and trying to solve problems together, particularly given the market reset that's going on and the economic drivers. So what are the technology game changers for the Murph of tomorrow? Well, I've outlined them here. Optical sorters, more of them, and in particular for fiber and flexible packaging. Robotics for containers to complement optical, and ballistic separators for better 2D and 3D separation. And then finally, quality assurance and quality control verification, as opposed to just making a bale and hoping for the best. So optical sorting, what's the driver behind optical sorting? Why? Well, first of all, manual reduction of labor is important. Improving the quality of the material by removing items through optical sorting, being able to increase your throughput dramatically. The machines can sort substantially faster and quicker in a smaller footprint, recyclables, particularly plastics, than people can. And there's consistency, meaning the machine works every day. People get tired, people don't show up, people go on breaks, people get distracted. There's been an improvement in worker safety by the reduction of people, and just in general providing value to the facility. So the technology that's used in optical sorting centers around three basic concepts. One is color detection, one is near infrared or NIR sensors, and the other is metal detection. And more recently, although it's not on the slide, you're going to hear a little bit more about laser, which is just another form of light to detect objects. And once those objects are detected, they're identified, and once they're identified through a computer programming feature, you can start to eject that material. So in principle, how the machine works, for those that are not familiar with it, the containers, number one, fall on a conveyor belt, and as the material passes underneath camera and sensors, the sensor being an orange, the light that's being shined is gray, the signal is picked up by this red box, and the red box sends an electrical signal to a valve that opens up air that ejects a puff of air and blows a particular item off to the other side of this splitter here. And by doing so, we can separate what you see here in green from what you see here that's not green. And there's different configurations. We can either blow in one direction, or we can blow in two directions. So we have what's called an air block valve. So simultaneously, we can make three separate separations. The green pointing in this direction, the red pointing across that direction, and whatever's left over falls in the middle. And we call that the eject fraction in the back, the eject fraction in the front, and then the pass fraction. So what are the new developments? I mean, I guess you guys can't miss the words I have here is fiber, fiber, fiber. And that is in general the interest of using optical sorter to improve the quality of fiber. And in how optical sorters are used today, they're substantially wider. They can be well over 2 meters in width. You can put them side by side as you see here. And we can use these optical sorters today extremely effectively, and there's a few manufacturers today that offer this, and be able to eject fiber, meaning if you have a stream of material of containers and fiber mixed together, you can target the fiber and eject it. We would call that positive sorting, the item that you eject. Alternatively, you could, if you have fiber and containers, and within that fiber stream, you've separated the fiber, but now you want to separate the fiber by grade or by removing the contaminants, what's not fiber, which are the prohibitives. You could eject the prohibitives. You could eject that aluminum can or that plastic bottle, or you can eject the outthrows if you're making a news grade or a mixed paper grade by ejecting the browns or the cardboard. So it would not be uncommon today in a Murph new facility that's being built to see optical sorting on fiber systems, largely because of not only what the market conditions are, but also for the reasons noted earlier, the lightweighting of material with these aluminum cans and plastic bottles getting squashed and getting stuck in between the paper, and the market conditions that are driving for higher quality products, and in general, the cost of labor and all the issues around having labor when a machine can perform that task. Changing gears, robotics, robots, or artificial intelligence. These are kind of the buzzwords you see in the advertising or at trade show floors or papers that are being written. So what can we say about it? What we can say is there's 4 companies so far in this market area. In general, what are we using it for? Quality control sorting, generally for containers. So let's say we optically sorted out all the PET and we want to make sure that we're producing a clean PET bale. Rather than having a person there QC that material before it runs off into a bin for baling, we would use potentially this robotic device that would do the quality control, meaning it would remove the HDP or the aluminum can or anything that got in there or the trash that shouldn't be there. So where do we see them is at the end of the lines, meaning downstream of the Murph towards the end. When will we see them? Well, for the next 5-10 years, we will start seeing them being used more commonly. And we know, obviously, there's been some that have been put in the past year. Reason is to improve processing. And how does it work? Well, it basically takes a lot of the features of an optical sorter, metal sensors, 3D laser cameras, and the NRC sensors. And with all that in the programming creates a memory concept in programming where the computer, if you will remember different objects based on their characteristics. And instead of using air to blow items out, it uses a mechanical arm. It moves a mechanical arm that can go to where the object is, select it, and then grab it and lift it off the conveyor belt by using either suction or grippers, with consideration of also how the material is laying on the conveyor belt, meaning if it's diagonally across, is it perpendicular, or is it longitudinal to the travel of the belt, and then locating where the drop chute is of where it needs to go. So in essence, it starts to function like a human in that sense. The technology itself is unit-based, meaning it's just like manual. So people will say that sorters can sort 45, 50, 60 pieces a minute. In effect, the robotic technology is pretty much at the same level, about 60 pieces a minute. But we have to be careful about ton per hour claims that are being made by the technology providers because they're not necessarily an accurate measurement, since you're sorting units, you're sorting bottles and cans, and you can only do so many per minute or so many per hour. And to convert it to weight, meaning tons per hour, depends on the density of that object. So be very careful in using those ton per hour claims because this is really a unit-based technology. It is capital intensive, and the results can be perhaps cost neutral. So if we have to watch that. The technology is going to continue improving naturally, so it's getting ready for what I would call prime time. And the market changes will drive this game changer. In other words, whatever the markets are demanding on the outside of the Murph, they will drive this game changer. So as long as Murphs can simultaneously increase its throughput, it's going to drive the use of this technology, meaning that it can get a return on its investment. And one of the things that would help, obviously, is a good commodity run where prices are running high, or the reverse, a bad commodity fall would be a defensive measure to put in robotics. A few of the technology company providers, Zen Robotics, you may be familiar with them, mostly working in the construction demolition waste arena. Bolograph, longtime supplier of technology to our industry, and you can see here the use of a suction grabbing arm here, and this arm travels in and out of this view and travels from left to right and lifts the item up. And another technology device here from Max AI, offered through BHS, Bulk Handling Systems, and AMP Robotics, also a suction technology. And MachineX introduced their machine this year at Waste Expo, which is also using a suction-based technology. So as I mentioned earlier, why robotics? Well, it maximizes final product quality, minimizes good product loss, reduces labor, improves safety. And in summary, it's following the route of optical. Sort speed per robot matches human. It's well suited for quality control after optical sorting, and it does achieve higher purity results than optical. It's very accurate. It grabs one object at a time versus optical that ejects, and you could get some collateral damage, meaning when you blow one object with it, you could be blowing others. But there's much lower throughput than optical, much lower. The grippers and suctions are prone to wear and tear. So these are some of the things to keep in mind. And the applications are all around the quality control features downstream, and also the potential of being used for, although I'm not aware of any yet, for removing browns on a fiber line and being the last chance sorter on the residue line, meaning as the residue is heading out to roll-off box or compactor, introducing a device like this that could basically remove a multitude of items off that belt. Changing gears now to screens. Most people don't like screens. There's safety issues, downtime, screens wrap and jam, loss of efficiency. The parts are very expensive. They create a lot of dust through the agitation. The efficiencies decline from the time you start running the piece of equipment until the next time you clean it. In between that period of time, the efficiency is declining rapidly, which means the products that you're making, the quality control on those products is declining as you go forward. So therefore, the need for them is declining. The interest is declining. What are the alternatives to screens? Well, one approach is just to change it and repackage it in a different way. It's still a screen, but reduce the angle of it so it's more horizontal. Change the speed so there's less agitation and it's more size driven. Change the diameter of the shafts so it provides an anti-wrapping feature, because the larger the diameter of the shaft, the more difficult it's for material to wrap around the circumference of that shaft. Making one product grade, meaning just try not to get involved in trying to make a news grade versus a mixed paper grade. Just make it all just one grade. And the alternatives, of course, are optical sorters and ballistic separators, where optical sorters and ballistic separators can do a lot of the same work a screen can do, particularly today. And just looking at some photos here on the left is what these screens, how these screens suffer. They just wrap very quickly with material all around the discs. And the photo on the right is a more modern version of a screen. They're much wider today, and their shaft diameter is much larger, as you can see in the photo, thereby reducing the potential for wrapping. So ballistic separators. Nice article written by Roger Gutentag in Resource Recycling about a year or so ago. Quick history, first started in 1994. It's not really a new technology, and it went through different periods of time in 1996, 98, and then there was a loss of interest. But Stadler, manufacturer, came to the U.S., and Sims, large processor of recyclables and the largest ferrous scrap recycler, I believe, in the world, installed some units in 2010 in New York. And the basic principle of the inclined belt was, as material dropped on the belt, as the belt traveled to the right, the objects that were three-dimensional would bounce and fall to the left, thereby separating from the flat material, which would be paper and cardboard, from those round objects, which would be bottles and cans that would run to the rear. This is in the most crudest version of a ballistic separator, conveyor belt. Then other technology advancement through a company called Besner, which is you feed the material in the upper right-hand corner, the belt travels from right to left, but meanwhile the belt's inclined, so material can actually roll down the edge of the belt. So this is like a three-dimensional, three-way activity here. And under this belt are devices that are banging the belt or beating the belt upward, which is causing this material to bounce. And that bouncing encourages the rolling of material. And this is just the city of Phoenix has a system like that installed. So ballistic separators today work with the same principle, but different equipment. And that consists of long paddles, this linear line here. And these linear lines move in an elliptical fashion, meaning they rotate up and down. They go up and down, like an elliptical machine for exercising. And these paddles are aligned side by side with each other, and as these elliptical pattern on an incline going up forces paper and flat objects to pull off the top, and the containers to roll towards the back, and there are openings in these paddles that allow glass and trash to fall through. So here's a photograph of them, and you can see the individual paddles here. Here's 1, 2, 3, 4, 5, 6, and the 7th and an 8th in the unit. Here's another close-up of them. And these paddles run on an eccentric crankshaft, and as it goes up and down, they individually move. One goes up, the other one goes down. This one goes up, that one goes down. And at the same time, they're moving forward. So that creates the agitation. The incline allows for the rollback. Here are some of the names of the manufacturers. Some of them may be familiar to you, some of them may not be. But there's a number of companies that provide this technology. And here's just a real close-up view here. These are little grippers that'll, and the materials would be traveling towards ups in here. And here's another view of these ballistic separators. Some of the features with ballistic separators, besides being able to change the speed of how they go up and down and they travel forward and back simultaneously, is you can change the angle of them, which is also an interesting feature. So why the interest in ballistic separators? Why introduce a new technology? Well, first of all, there's no wrapping on them at all. And there's no dust. You don't get that agitation with the paper where things are flying around all over the place and creating dust and commotion. So these two objections of screening technology have pushed a large interest in ballistic separator. So why is there hesitation in the marketplace? Why are people not just ripping out all their screens and putting in ballistic separators? Very simple, throughput limitations. These ballistic separators, because they have less agitation, once the machine gets flooded, it's difficult to move a lot of throughput. So the manufacturers of the ballistic separators are working on how to improve their throughput by making the machines wider, stacking the machines, and doing other techniques. And we expect to see that in the future as being a direction for the marketplace. Some of the features I mentioned earlier is the ability to adjust the angles, fans, covers, having different size screens, the width of the units ranging 5 feet even up to 17 feet in different paddle styles. So there's a lot of options available with ballistic separators. Changing the subject to retrofits. So there was a nice article in Recycling Today magazine this month of June where I was interviewed, and these were some of the questions I was asked, so I just put them up here real quick if you missed it. Because anytime we talk about technology and we talk about the past, present, and future, in effect, we're also talking about retrofits, because by and large, there's only a handful, maybe 5 facilities that are built in the United States a year that are new. In general, all the activity is about retrofits. So how do we accommodate a retrofit, and what are some of the questions that should be asked when doing a retrofit? Is essentially you're dealing with your operating plan. And so you would want to know how you staff your operating hours, how you're producing your different grades, in what order you're baling different products, and how you're processing different materials. And traditionally, all those kind of questions, you wouldn't necessarily consider this under a retrofit, but a retrofit implies that you want to change. So if you want to change your facility based on a capital investment, you should also look at changing your operating plan as well. And maybe you change your operating plan first, and that may diminish the need for your retrofit, perhaps. Diving deeper, the first question a Murph operator should ask is always, what is the problem we're trying to solve? Is the problem that we're trying to solve really an equipment problem? Probably not. It's either a financial problem where the facility is not making money, or it's in the red, or we have some financial issues, or we're trying to solve a throughput problem, meaning we're not able to get enough tons through the plant, or it's a material quality problem. We're not producing a material that meets the market quality. Those are the problems we're really trying to solve. So focusing in on what is the problem we're trying to solve will start to allow you to think more openly and more objectively about how to solve that particular problem. And it could be equipment, it could be a combination of equipment and other things, or it could be something other than equipment. And then from there, one has to look at how these items are interconnected with each other. So is training effective? Is the equipment I already have reaching the point of obsolescence? Do I have bottlenecks on the facility? Is the incoming material different? And if it is, how can we quantify that besides just saying that it is? And how do we really know what our performance level is if we don't quantify it? So trying to do better is great and admirable, but better than what? You have to know where you are as a baseline. Other comments on retrofits is what should an operator look for when selecting equipment manufacturers? Meaning, who do I buy from and what do I buy? So here are a few areas of conversation. What is the capacity of that piece of equipment, production? And I think we discussed earlier that capacity can be measured in tons, but it could also be measured in terms of volume, and that's important since it's unit-based. How safe is that piece of equipment? What is the cost? And what is the indirect related cost of that equipment? Meaning, what kind of power do I need? Platform supported, conveyors, compressed air, dust control equipment. What are my permitting requirements? So there's a lot of collateral costs or indirect costs related to the equipment. And what is the equipment manufacturer's flexibility to customize the equipment? After all, if we're doing a retrofit, I have an existing facility. So I don't think I can really buy something that's going to fit right in. So I either have to change what I have, or the manufacturer has to be flexible enough to customize this piece of equipment, make it shorter, make it longer, wider, narrower, etc. And has the individuals from the engineering team actually been to the facility, not the salespeople, but the engineering people from the company, studied and thoroughly analyzed what really would be the right type of equipment that might be the best piece of equipment. And of course, the quality of the piece of equipment is critical, as is the ability of the equipment to produce the quality products. So they go hand in hand. Naturally, throughput capacity seems to be the yardstick everybody wants to talk about. The 25 ton per hour or the 30 ton an hour. So throughput is naturally a factor. And then safety. And it's not just the safety of the piece of equipment, but also the implementation of that piece of equipment. Does it make my plant safer, or do I now result in more safety issues? So some final thoughts. We have lots to do, and we have huge investments need to be spent. 70% of our waste is still unprocessed, so there's a lot of opportunity here of work in front of us and of what is being processed. We're still not there in terms of doing it very well, and we need to keep working on moving towards a fee-based structure for how the business model works rather than revenue-based. Commodity markets are reacting to the evolving ton, meaning as the ton became more contaminated and more issues, markets today are pushing back and they're looking for 0.5% contamination in bales of fiber on the global market side, but the domestic markets are reacting as well to what the global markets are. So we're seeing the domestic markets are tightening right in line with the global markets, and that's putting a lot of pressure on the operations. Last comment is our company, together with the publisher of Recycling Today, sponsors a conference once a year in Chicago. It's called the Murph and Recycling Plant Operations Forum. It is solely dedicated to the conversation of plant operations. So if anybody is interested, you could register for that. It's a one-day forum where there's presentation made from the various manufacturers and Murph operators. So with that, I am completed the presentation and available to answer any questions.
All right, thank you, Nathiel. We're now going to field some questions for our presenter. Again, if you have a question, please enter that into the GoToWebinar dialog box. So we do have some questions already. So on page 36, when you showed the various MRFs with the 65-35 split, single versus dual, does this reflect the number of MRFs or the tons processed?
Number of MRFs.
Okay.
Number of facilities.
Okay, have there been any new developments that would allow an economical sorting of glass at MRFs?
No, is the short answer. Economical sorting of glass generally is done in the concept of particle size. So, glass is broken, and there's been efforts to screen glass out, and that's pretty straightforward, where we screen out the fine material. Anything less than 1/4 inch or 3/8 of an inch is screened out and considered to be not going to go to a facility that's going to optically sort the glass into its different colors. And then there's the need to vacuum off and remove all the paper labels and the shreds and things like that. But generally, the problem with glass, it's a tonnage issue. Although by weight, it may seem like a significant amount, the amount of material and glass in proportion to the type of equipment and CapEx and OpEx to run that equipment, the numbers just don't add up. The math doesn't work.
Okay, follow-up question to that. Can optical sorters find the caps and lids of plastic containers?
Optical sorters can definitely find the caps and lids of plastic containers, but if they're screwed onto the cap, if the way a bottle is constructed is you have the body of the bottle, and then you have the cap that's screwed on to that body. If the cap is screwed on, it's going to ignore that type of plastic. It's going to look at the body, which is the predominant item. It's not going to be able to separate the cap from the body. If the cap was individually on a conveyor belt and there was just nothing but caps, no problem. It would be able to separate those.
Okay, this question has to do with UPCs. We understand that we're losing UPCs with glass and in PET bales. What are your recommendations for capturing more all aluminum, robotics, or any additional eddy currents?
There should be no reason in the world to lose any aluminum in either of those two scenarios. First, in glass, usually glass is recovered through screens, and the whole diameter of the screen needs to be designed to retain the aluminum can, so the aluminum container or can does not fall through. So it sounds like there's a screening problem potentially there. On the issue of aluminum in the PET bale, that is a function of a weak or inferior eddy current separator. Eddy current separator technology has dramatically changed. The technology that's used today in a brand new facility is substantially stronger, wider, and much more accurate in ejecting the aluminum can from what it was ejecting, 5 or 10 years ago. And we all know an aluminum can has become very thin in comparison to what it used to be. So it's substantially more difficult to remove that aluminum can. And if you're expecting an existing piece of equipment to do that job, that would be difficult to do. Yes, you could add optical sorter to remove aluminum from the PET bale, but that technique could be done with the robotic, meaning instead of a person on the conveyor belt that would remove the aluminum can, you could also use the robotic technology to do that. But adding a person there to remove that aluminum, one would have to do the math and see whether the economics of that pays for that individual.
Okay, what is the average screen size for a U.S. facility currently, and how rapidly do you expect facilities to change over to ballistic separators?
I'm not sure I know what you mean, what the question is in terms of screen size, whether in terms of the whole machine itself or the openings of the screen. So I'll try to answer in both ways. Screen widths, or the actual width of a screen machine, has gotten quite big. They easily could be 2 meters in width. In terms of opening, or the openings within the screens, there's been a tendency to make them substantially smaller on the OCC screens because the size of OCC has reduced in size because of what we call the Amazon effect. So there's a lot of changes happening in terms of screen sizes in width and in opening. The problem with all those changes is whatever you put in your facility today, within 2, 3, 4 years, it's not really ideally suited for the stream because the packaging industry keeps changing and consumer habits change, and now you're kind of stuck with a piece of technology or screen opening, and they're not easy to adjust. Optical sorters are constantly adjustable, so they don't suffer from the difficulties of having a screen opening that's fixed in size.
Okay.
Hope I answered that question.
Okay. What would your estimate be for the capital cost of a modern 300 tons per day residential single stream Murph?
All in, could be in the 20 million, 25 million, building and equipment. That's a big number in comparison to what it was in the 90s or in 2000, which would have been in half of that kind of number.
What do you see as a long-term trend for collection / recycling of glass?
You know, it's an interesting question because the subject of glass comes up every year, and that question gets asked constantly. And what we do today with glass is almost identical to what we were doing 25, 30 years ago. So the only thing that's going to change is a different market, and the market would drive that. So there's been more recently quite a bit of activity in trying to develop facilities that would take the glass and, rather than color sort the glass, produce products that would be used in the cement industry as a pozzolan, or use the glass for the sandblast abrasive industry. When you move into that industry, the value of the glass moves from, you know, a $5, $10, $20 a ton product to a $200+ per ton product. So if those markets mature and develop, and they have some success, they will then drive Murphs to see glass become a commodity that would be able to move, as opposed to ending up in a landfill and as quote unquote alternatively daily cover.
Okay, here's a good question. Can any Murph equipment in use today get a bale down to 0.5% contamination, which is in line with China's new guidelines?
You know, somebody was going to ask that question, and the short answer is don't know. Because you could make one bale that gets there and the next bale doesn't. So it's pretty much a crapshoot. The biggest problem here is the amount of money one would spend to attempt to get there and not get there. I know of a couple of facilities right now that are hovering around 0.5%, 1%, very regularly, steadily are able to do it. Most of it is because they're fulfilling domestic markets, not global markets, but it requires a tremendous amount of people, like double the amount of people, and running the facility much slower. Adding more optical sorters has the greatest chance of getting there on the fiber line, and particularly adding them in a way that changes the way we think a little bit in terms of, traditionally paper was always a negative sort, meaning whatever fell off the belt was considered your paper grade, and you just positively removed any contamination. Based on the changes of paper composition, the more stringent paper guidelines for markets, we'll see optical sorting, but we're also going to see it used in the reverse fashion, meaning positive sorting fiber. And that can be done because an optical sorter can sort material so much faster than a person can. And by doing so, it sort of changes that thinking. So went about a long answer to basically say that it's questionable whether anybody is really accomplishing the 0.5% day in, day out, anywhere. Lots of people are working towards it, though.
Right. Are there any worker safety related implications of recent changes in Murph technologies?
One of the largest worker safety implications is the new ANSI standards requires what's called a process hazard assessment to be done as part of a facility upgrade, meaning traditionally, rather than just thinking about whether it's safe or not or how safe it is to actually get a third-party professional that looks at all the hazards that a worker could be subjected to in and around the equipment, whether it's a hazard of injury to their eye, to their ears, to their lungs, to their arms, trip and fall, and preparing a written document that goes through that entire process and validates that if a worker is put in front of a piece of equipment, are they going to be safe working in that environment? It's a rigorous process. It's a formal process. It's something that is being required of any new facilities, and there's also a requirement for any major retrofit. So that's one example of a change.
What is the #1 source of contamination at a Murph?
In terms of a headache for a Murph operator, plastic film. Plastic film everywhere. It ends up on the floor, ends up in the ceiling, and the rafters, and the bales, stuck in between all the fiber. It's all over the place. From a weight point of view, it's virtually meaningless. But from an appearance point of view, it looks awful, and it gets all tangled up around equipment. So it wraps around gears and shafts and return idlers and so on. So it is definitely a source of a headache to a Murph operator.
You think that's mostly plastic bags or just regular like stretch film or other films?
It's grocery bags, little grocery bags.
Okay. Would you install robotics as a quality control in any project you are designing now, or is the technology not ready?
I don't think the technology is ready there from an economic standpoint. I think it is ready from a technical standpoint, but I'm not sure it's there on an economic standpoint. But certainly on any new project we would consider is the implication of how would we add that in the future. And on the same vein, we would also think about how to add or use ballistic separation, and also how we would use more optical sorters. It just wouldn't be robotics. It would be all three of those. Ultimately, how would this facility run and operate with much less people? How do we get from 30 to 40 people to 5 people? That's how we would look at it.
What do you think of the combination products like singulation optical sorters, like those offered by CP or Alchemy Sort?
Not sure I understood the question, but I think it's important that all bottles and containers or fiber is always singulated as part of an optical sorting technology. If they're not singulated, when the air valves eject and are blowing off the air, you will not get the same level of purity in the finished product. So it's important to singulate, and in doing so also, the other objective is to keep the object from moving, meaning after it's been identified, it still has to travel down the conveyor belt, perhaps another 12, 14, 16, 18, maybe 30 inches before it falls off the end. And in doing so, it needs to stay in that position, because if it moves, then it creates some issues for the ejection.
What is the trend in terms of the average gross operating cost per ton for the larger Murphs?
Well, rather not get involved with discussing cost numbers, but in today, I would have said a number, but today I would say any number I would say is irrelevant, because right now Murphs are throwing a tremendous amount of money in labor and slowing down lines and doing all kinds of things to deal with the market conditions. So if I'll use a number, if a number was $50 a ton in terms of a processing cost outside of residue disposal and outside of maintenance and other issues, that number is growing substantially, and I'm not sure everybody has a good handle yet on what their true costs are on a sustainable way. So in short, whatever numbers anybody's put out there or heard in past years, they're all getting recalibrated right now.
Okay, last question. There is a significant amount of press around fires at Murphs. In your opinion, what are the causes and what can be done from a design perspective to help mitigate this issue?
Causes run around the following. A lot of the fires occur within the screens themselves, material wrapping around the shafts of a screen that's moving at a very high speed of rotation. Plastic is building up. Plastic is rubbing against plastic. And we all took eighth grade earth science or some version of that. And when you rub things together, you start creating heat, which eventually will create the opportunity for a fire to begin with a spark. So that's one issue in that area. Another area of fire are inside balers. Certain items that end up in balers, like aerosol cans, have the potential ability to start fires. So those are the two kind of main areas. Third area is in the drum feeder, when the loader is loading the material into the storage bin or the drum feeder, and the drum roll is moving around and the material is being pressed up against it. We've seen quite a bit of fires happening at the drum feeder itself. So the drum feeder, the screens, and the baler. And then finally, I would say, unrelated to equipment, fires occur on the tipping floor because we get what's called a hot load, meaning there's material that's dumped on the floor and it's just smoldering internally. And then as soon as the loader picks up the material and feeds it oxygen, it ignites and goes on fire. And some people would agree, including me, that lithium batteries and other types of electronics are the causes of those fires, meaning the loader drove over it, and as the loader drives on it, it actually causes a small little explosion, if you would, which causes the ignition and the fire begins.
Okay. All right, so we're gonna close up now. Great questions, everybody. Sorry, we got some feedback there. So again, this webinar, like all the webinars in this series, has been recorded and will be made available via YouTube links on both the National Recycling Coalition and Recycling Market Center websites. Thank you again for joining us, and thank you, Nathiel, for taking time out to make this presentation. We will hope you will join us for next month's webinar, and please visit the NRC and RMC websites for schedule updates. And have a great day, everybody.
Thank you, everybody, for the opportunity. Have a great day.